Right, hi. So we are going to work through the 2016 paper 2. So I've already done paper 1 and that's up on the channel so far, as well as the 2014 and the 2015 papers if you are looking for those. Right, so we have a drinks manufacturer is reducing the sugar content of one of their fizzy drinks by 8% per year, not 10%, over the next 3 years. The sugar content of a standard can is currently 35 grams. Calculate the sugar content of a standard can after 3 years. So, if they are reducing by 8%, that means it's going to have 92% the amount of sugar. So, that's our percentage, which will be 0.92. So to find out our value after 3 years, it's going to be that our original value, so 35 times the 0.92, and then our percentage as the decimal is then put to the power of our however many years it is. So because it's 3 years, it's to the power of 3. So we then put that into our calculators and we get 27.25408 grams. You can round that if you want, or you can just leave it as the given decimal with all those decimal places there. So this question is worth 3 marks. You get 1 mark for the 0.92. You get 1 mark for the 35 times 0.92 to the power of 3, or if you've done it in 3 steps, that will also work, and then your final answer is your 3rd mark for this question. Okay, so now on to question 2. Okay, so for question 2, we've been told that a pollen sample weighs 12 grams and it contains 1.5 times 10 to the power of 9 pollen grains. So if we want to know the weight of 1 pollen grain in grams, so we know that 1.5 times 10 to the 9 grains weigh 12 grams. So 1 gram, I'm going to have to divide both sides effectively by 1.5 times 10 to the 9. Working it the same way as you would with any kind of ratio. It says give your answer in scientific notation. The thing to be careful about with scientific notation is that you need to make sure that your number is given between the values of 1 and 9.9. So if you have scientific notation, you have 10 point something, you need to move your decimal place and add 1 to your power. When we do that, we get 8 times 10 to the minus 9 grams. The other thing you can do with this is your calculator, if you're using a Casio, at the least has a section, has a mode where you can put it into scientific notation. So rather than it giving you your answer as like 0.000 example 8, it actually puts it into scientific notation for you, no matter how big or small the number. But obviously if you do that, you have to remember to change your calculator back afterwards. Right, so let's go through the marks for this one. So the first mark for this is the correct method, so knowing to divide the 12 by the 1.5 times 10 to the 9, and then your second mark is for your answer given in scientific notation. Okay, so that was straightforward, so let's go on to question 3. Right, so for question 3, we have been asked, AB represents the vector u, so that's here, and we have B to C represents the vector v. It's a parallelogram, so what we know about parallelograms is that the vector v, BC, is also going to be the same as the vector here. So we can write that on. So a little bit that we know, so that's also vector v. Also, because it's a parallelogram, how we get from A to B, or the vector u, is also going to be the same as the one up the top. So let's see. and that's going in that direction, and that is going in that direction, so it's still the same ones. So we have to express how to get from here to here in terms of v and u. So there's different ways we can do it. Either's okay. So if we're going to do this, if we follow the path of that vector, so to go from b to d, we're going to have to go like the long route. So we're going to have to go along here. So because it's in the direction of the vector, that is the vector v. And then because we're going in the opposite direction, that means it's a subtracting a vector. So we get BD is equal to V minus U. And that is it. That's 1 mark. That's all that question's worth. Right, so on to question 4. Okay, so we have factorizing. So it says factorize fully and it's worth 2 marks. So that means you're going to have to do 2 things. So we have 3x squared minus 48. We have 2 terms here. 1, 2. And we have a subtract in between, so it means we're going to have to kind of do a difference of 2 squares. However, this 3 is stopping us, and that 48 is not a square number either. But hopefully, if we can take out that 3 as a common factor, we're going to end up with a difference of 2 squares that we can then do. So 3 bracket x squared. So we're going to have to do 48 divided by 3. Doing that, you can either obviously do that in your head or do a ternary sum. So we get 4 goes into 3 one time with 1 remainder, and then we get a 6. So we get 3 bracket x squared minus 16, close our bracket. So we can write x squared minus 16 as x squared minus 4 squared. Okay, that was me combining the words 16 and 4 there for a second. So what we have, if we have a difference of 2 squares, so if we can express both of those terms as a square number, we can factorize that as 2 brackets where they both have the same coefficients or values in the brackets. One has a plus and one has a minus. So that's just a difference of 2 squares there. So for this, it is 1 mark for getting your factor of 3, and then the other one for getting it finalized. So it's the 3 and the x squared plus 16 actually. So just the 3 wouldn't be enough. You need to have the 3 and the x squared minus 16 correct to be able to keep going. Right, on to question 5. Right, so for question 5, I've made this one a little bit bigger actually than I had originally planned, so that we can kind of draw inside our diagram. So we have a circle here with center O, and we've been told that AB, so this line here, is a tangent to the circle, and so is C to B. So we know that they meet the radius at 90 degrees, so we can put that in. So this is the information that's been given to us from the question. So we know that those 2 angles there make a right angle, because that O to A is a radius. If we had the radius O to C, that would be a right angle as well. We've been told that we have parallel lines OD, well ED and AC as well. And we've been told the angle AOD, so the parallel lines are this one and this one, so that's the arrows there. And we've been told that this angle here is 143. So we need to do some working, and it's easiest to just do it on the picture. So the first angle that's going to be easiest to work out is this one in here, because we have a straight line, and a straight line adds up to 180. So if we do 180, take away the 143, so 0 take away 3, 7, 1, so we get 7, and then 3, so we get 37 degrees in here. Right, so next thing is knowing about our parallel line. So in a parallel line we have I'm going to highlight it just to make it more obvious. So that in there is a alternate angle, or a Z angle you might have heard it called. So in there, they are both going to be equal, so we're going to have 37 in there as well. So we know that these two angles in here, so OAC and CAB, are going to have to add up to 90 because of the tangency there. So that means that this angle in here is going to have to be 90 take away 37. So we get 53 degrees in there. So because of the fact that those lines are both tangents, we end up with isosceles triangles, so that's 53 degrees in there as well. Right, so we know that the angles in the triangle add up to 180. So we have 53 add 53, so that's 106. For those two together, the CAB and ACB. So our last angle has to be 180 take away 106, which is 74. So this angle in here has to be 74 degrees. So we should write angle CBA is equal to 74 degrees. It's the same as ABC, as long as the letter in the middle is the same. It doesn't matter the order around in which they go. So our marks for this one are 1 for the 37 in there, 1 for the 53 for CAB, and then 1 for the 74 in there. So for this question, it is an awful lot about recognizing the angles inside there, and you can just draw on the diagram because you're allowed to draw on the paper, so it's not a problem. Right, so let's go on to question 6. Right, so we have question 6. So Jack called his internet provider on 6 occasions to report a connection problem. On each occasion he noted the length of time he had to wait before speaking to an advisor. For part A, we need to calculate the mean and the standard deviation of the times. So mean is what we generally kind of call average. So we need to add them all up and divide them by how many there are. So we have 13 plus 16 plus 10 plus 22 plus 5 plus 12, all divided by 6. And that gives us an answer of 13 minutes when we put it in our calculators. Right, so for standard deviation there are 2 different formulas. I'm going to use the one that I'm most comfortable using. However, if you've used the other formula, please feel free to skip this and not let it confuse you, and just use the one you've used rather than this other method. So the way that I would teach it is to find x and x squared, and then find the sums of each of them. So we have 13, we have 16, 10, 22, 5 and 12. So we're going to have to find the sum of both of those at the bottom. So 13 squared is 169. 16 squared is 256. 10 squared is 100. 22 squared is 484. 5 squared is 25, and 12 squared is 144. So if we add all of those up, so we're doing 169 plus 256 plus 100 plus 484 plus 25 plus 144, we get 1178. And for our sum of our x's, we have 13 plus 16 plus 10 plus 22 plus 5 plus 12, so we get 78. Right, so the 2 formulas you actually get given are the s equals the square root of the sum of x minus x bar all squared over n minus 1. That's the one I'm not using. I'm using this one, which is s equals the square root of the sum of x squared minus the sum of x all squared over n all over n minus 1. The second one may in fact seem to be more confusing. However, it is more accurate when our mean is a decimal. Right, so we get s equals the square root of the sum of x squared, so we get 1178, minus the sum of x, which is 78 squared, over 6, because that's how many numbers we have, all divided by 5, because it's n minus 1, so 6 take away 1. When we put that into our calculators, there's no need actually at this point for you to work any of that out on its own. You can just put it straight into your calculator as it is. Your calculator can handle it. And you get 5.7 if we round it to 1 decimal place. So we get 5.7 minutes, 1 decimal place. Right, so for part A anyway, our marks that you get for this working, what happens is you get 1 mark for finding your mean, you get 1 mark for these two, so the sum of x and the sum of x squared, 1 for subbing into your formula correctly, and the 4th mark is for your answer once you've put it into your calculator. So even just that small mistake somewhere, you can still pick up quite a lot of marks for these questions. Right, so part B says Sophie also calls the same provider, and her mean time is 15 and the standard deviation was 4.3. So we need to make 2 valid comparisons between the 2 waiting times. So I've just, as you've seen, rubbed that out over there so we can put part B up here. So when we're doing this, there's really specific phrasing that they're looking for. So standard deviation is to do with consistency. So we need to make a comment to do with the means. So we can say, if we look about it, so the mean for Jack was 13 minutes and the mean for Sophie was 15. So we can say on average, Sophie's wait time was longer. Okay, so it makes sense to comment about the one they've given you to compare with. And then, so that's 1 point, and our second point has got to be to do with the standard deviation, so that's comparing the means. And then we need to compare the standard deviation. So because the standard deviation is smaller, that means her wait time is more consistent. So consistent is a really important word that they're looking for. So generally, Sophie's wait time was more consistent because the standard deviation was lower. Right, so the really important word there is the consistency. It's the same with interquartile ranges. Is they're wanting to know about the consistency, that's the word, consistent. So it's 1 mark for each statement. Right, so on to question 7. That was quite a long one. Okay, so we have a carton in the shape of a large cone. Is the shape of a large cone with a small cone removed. The large cone has a diameter of 32 centimeters and a height of 24, and the small cone has a diameter of 18 and a height of 13.5. So we are going to have to find the volume of each cone. So volume LC, large cone. so 1/3 pi r squared h is the formula. Right, so if we put in our values for the large cone, so for the large cone, our diameter is 32, so our radius is half of that, which is going to be 16. So 1/3 times pi times 16 squared times 24. So what we get when we substitute both, when we put all that into our calculator is we get 6,433.98 centimeters cubed. That's 2 decimal places. Right, so we need to work out the volume of the small cone. So the diameter of the small cone is 18 centimeters. There should be centimeters on all of these as well, because units are important. So the radius of the small cone is going to be 9, because we half it to find the radius. Formula stays the same, so it's 1/3 pi r squared h. So it's 1/3 times pi times 9 squared times 13.5. So again, putting that into our calculator to get a value, we get 1,145.11 centimeters cubed to 2 decimal places. So the volume of the container is going to be 6,433.98 take away 1,145.11. So we get 5,288.87 centimeters cubed, but it asks for our answer to 2 significant figures, so that would be 5,300 centimeters cubed to 2 significant figures. Right, so marks here. We get 1 mark for showing evidence of trying to find the difference between 2 volumes. So knowing that it's one volume take away another one and showing something gets us our first mark. We get our second mark for finding the volume of the large cone correctly. Our third mark is the volume of the small cone. Our fourth mark is for actually following through and getting the subtraction. And then our final mark is for our correct rounding to 2 significant figures. Okay, so with these ones, it's just careful you use the correct formula and make sure obviously you're using the radius rather than the diameter in your equations. Okay, so we're going to go on to question 8. So for question 8, we get told that a set of ladders has legs 150 centimeters and 140 centimeters. When the step ladder is fully open, the angle between the longer leg and the ground is 66 degrees. And we've been asked to find the angle between the shorter leg and the ground. So we have a triangle, there's no obvious right angle, so it's either the sine rule or the cosine rule. Because we only have 2 sides, and it's 2 sides and 2 angles, that means it's the sine rule. So let's label these. So we have A and A, B and B. So with the sine rule, it doesn't matter. So you probably know it as A over sine A equals B over sine B. But it actually doesn't matter what way up you write it. So this case, because we're finding the angle, it's actually probably easier to put that on the top than it is to put the side. So we get sine B over B is equal to sine A over A. So if we put in our values, so we get sine x degrees over 150 is equal to the sine of 66 degrees over 140. So we can then multiply both sides by 150 to get rid of the 150 on the bottom of that fraction. So we get sine of x degrees is equal to sine 66 over 140 all times by 150. So at this point we're trying to find x, so we need to do the inverse sine of both sides. So x degrees is sine to the minus 1 of all of that. So sine 66 degrees over 140 times 150. You can put this into your calculator in bits if you want, but I kind of find it easiest to just shove it all in one go. But that's because I've obviously have a really good grasp of using a calculator, as it comes from being a maths teacher. So when we put that in, we're going to get 78.18, so 78.2 degrees. Okay, so this question is worth 3 marks. You get 1 mark for correct substitution into the sine rule, another mark for rearranging the formula, and then 1 for getting to x. Right, okay, so that wasn't too bad for a sine rule question. Actually, it was quite kind for a sine rule question. So we're going to go on to question 9. Right, so we have a completing the square question. So we've been asked to express x squared plus 8x minus 7 in the form given there. So when I'm doing these, what I kind of think of it as, we need to make that square bracket that gives us that value there. So the square bracket that is going to give us our x squared plus 8x is going to be x plus 4 all squared. Because if we do x plus 4, we're going to get x squared plus 4x plus another 4x plus 16. So x squared plus 8x plus 16. So that gives us those first two terms. So we have these here, these two that we're looking for. However, we have a pesky plus 16 when we multiply that bracket that we don't want. So we have to take away that 16, and that makes that bit inside the squiggly bracket, the same as this bit here. So we need to then take away 7, because the take away 7 we've not really done anything with. So we get x plus 4 squared, take away 16, take away another 7, which is going to be take away 23. Okay, so this question is worth 2 marks. When I was doing that there, I actually kind of went through the main, the reason why it works and stuff there. So depending as well, there's videos from higher unit 1 that explain how to complete the square if you weren't sure kind of what was going on there, especially as well some of the harder completing the square questions where you either have a negative x squared or a constant in front of it. There's videos that explain that just from scratch. So you get 1 mark for the x squared plus 4 and then 1 mark for the minus 23 for that question. On to question 10. Okay, so we need to simplify n squared all cubed times n to the minus 10, giving our answer with a positive power. So we have n squared all cubed times n to the minus 10. So BODMAS says we have to deal with our brackets first, so it's the same here. So anything of a power to a power, so n squared, just bringing it over to the side, all cubed, means n squared times n squared times n squared, right? And when we have something times together with powers, we can add them, so we end up with n to the power of 6. The quick way to do a power to a power, though, is to times them together. So n to the power of 2 times 3 times n to the power of minus 10. So that's n to the power of 6 times n to the power of minus 10. That's kind of like an extra line of working in there, just to say what I was saying out loud. So now because it's both n, we can add our powers, so we get n to the power of 6 plus minus 10. So that is n to the power of minus 4. It's asked us specifically to give our power, our answer with a positive power. So if we have a negative power, we can move it to the bottom of a fraction and make the power positive. So we get 1 over n to the power of 4. So for this question, you get 1 mark for the n to the 6, 1 mark for the n to the minus 4, and then 1 mark for the 1 over n to the power of 4. So index laws, just be careful when they are multiplied you add, and when they are dividing you subtract, and then if it's a power to a power you multiply. And to make a negative power positive you move it to the bottom of a fraction, or you flip it from being the top to the bottom or the bottom to the top. So you just move it within the fraction. Right, on to question 11. Right, so for question 11 we have these two pictures are mathematically similar in shape. The cost of each picture is proportional to its area, so that's the important bit there, is the fact that it's to do with our area. It's not to do with the length that it's proportional to, it is specifically area. So the large picture costs £13.75, so we want to find the cost of the small picture. Okay, so this is, because we're going from large to big, so it's going to be a reduction scale factor, and it's linear because we're looking at the lines. So because we're doing reduction, it's large over small. So we get 6 over 10, which is 3 over 5. So when we are doing area scale factor, area, the way that I remember it is you find the area of a square and the volume of a cube. So when you're finding the area scale factor you have to square it. If you're finding the volume scale factor you have to cube it. So the area scale factor is that 3/5 squared. So that gives us 9 over 25, because when you square a fraction you square the top and you square the bottom. So the cost is going to be 9 over 25 times that £13.75, which gives you a cost of £4.95. Pretty decent, good price for a picture. Right, so you get 1 point here for their scale factor of 60 over 100. Your second mark is actually for this line here, so for knowing to square the linear scale factor and multiply it by the cost. And then your third mark is for your final answer of £4.95. So let's go on to question 12. Right, so we are changing the subject of a formula. I personally have always found these okay, but I know that this is something that quite a lot of people find really quite complicated. When I'm doing these, I think about I'm unpicking or unraveling the equation to find what I want to change the subject to. So if I was going to work out this side of the equation, I need to unpick it. So what I would do to the t, so it's k that we want to do, so I would times it by 4t, then I would take away p, then I would square root it. So to unpick it I have to do that in reverse, so I need to get rid of the square root first, because that's the last thing I would do if I was doing this in order, so I have to get rid of it first. So you get rid of a square root by squaring, so we end up with L squared is equal to 4kt minus p. The next thing I would have, so working in reverse, I square rooted it, then I would have done this is going backwards. I would deal with the minus, the second last thing I would deal with was the minus p, so I need to deal with the minus p, and to deal with that I need to add p to both sides. So I get L squared plus p is equal to 4 kt. And then the first thing I said I was going to do would be multiply k by 4 and by t. So I then need to do the opposite, so I need to divide by 4 and t. So I get k, and I get L squared plus p over 4t. I can write that round the other way, but you don't have to. So L squared plus p over 4t. Right, so for this question, worth 3 marks. Your first mark is for knowing to square. So L squared equals 4kt minus p. Your second mark is for that line there, and your third mark is for that one there. So you get a mark for knowing to square both sides, for knowing to add p to both sides, and for doing it correctly, of course, and for then dividing and getting the answer when you divide by 4t. Question 13 coming up next. So question 13, another thing people seem to not be too fond of, is algebraic fractions. I think this generally comes from the fact that people are generally not too happy with fractions when they have numbers in them, let alone algebra. So our rule for adding fractions is that they have to have a common denominator. If the common denominator isn't obvious, which with algebra it generally isn't, our common denominator comes from multiplying together our two denominators. So if we just had, I'm going to finish writing that first. So if we just had a fraction over 5 plus another fraction over 7, our new denominator becomes 5 times 7, and that one becomes 5 plus 7, 5 times 7 as well. That's all I've done there is I've times together my two denominators. So our numerators, what happens is we aren't changing the value of our fraction, so we need to multiply the numerator by the whatever we've multiplied the denominator by as well. So in this case, it's going to be whatever's on the top times by 7, and in this case it's going to be whatever was on the top times by 5, because the 5s don't appear in the original fraction on this side here. There's no 5s there originally, and there's no 7s there originally. So here, there's originally, this one's there, this one isn't, so that bracket needs to go on the top and multiply our numerator. So we get 3x plus 1. So if we wanted to, we could simplify that fraction down by scoring those out, and we would get back to what we started with. So the other side, the bracket on the bottom we don't have, is the x minus 2. So that's what we have. So we can now write that as 3 as one big fraction, 3 times x plus 1 plus 5 times x minus 2. It can be best to do it this way, especially if there's a subtract as well, so that you're not mistakenly forgetting to multiply out your subtract through the whole bracket. So we then, on our numerators, multiply our brackets and kind of collect our terms. So we're going to get 3x plus 1, 3x plus 3 even, plus 5x minus 10 all over x plus 1, x minus 2. So if we sort out our numerators, we're going to end up with 8x minus 7 on the top, and then x plus 1, x minus 2 on the bottom. So what I've done there is I've looked at the 3x and the 5 plus 5x gives me the 8x, and the plus 3 take away the 10 gives me the minus 7. So marks for this question, question 13, come from, we get 1 mark for knowing our denominator. That wasn't meant to be a highlighter, but it works. We get 1 mark, our second mark for getting our numerator correct, and then our third mark for simplifying our numerator. So in this case, even if you're not sure what you're doing, and you're in the exam and you get totally stuck, make your denominator by multiplying together the two denominators from each separate fraction. And that's 1 mark, because to an extent I know you want to get the best mark you can, but you need to be clever with your marks, and algebraic fractions is normally something that quite a lot of people struggle with, certainly at National 5 anyway. So it's worth, at the very least, not going, oh no, I can't do algebraic fractions, I'm just going to leave it. Do something, make the denominator even if the numerator isn't right. Okay, so we'll go on to question 14. Right, so we have 2 tan x plus 5 equals minus 4. So we need to solve this between 0 and 360. So we need to arrange it to get tan x equals a number to start with. So we're going to take away the 5 from both sides. So we're going to get 2 tan x equals minus 9. And then we're going to get tan x equals minus 9 over 2 when we divide both sides by 2. So at this point comes our cast diagram. I actually got taught it because I was very musical at school, by soprano, alto, tenor, and then it doesn't follow the pattern anymore, but that's where the C has to go, which is why I write it slightly odd. Random story fact for you there. Right, so tan is negative, so that is going to be our second and our fourth quadrant. So this quadrant here is 360, take away our acute angle, and that one is 180, take away our acute angle, because we're working from there going back that way, and from there going back that way. So we need to find out our relative acute angle. So we need to find out what the angle would be in this first quadrant here, and that's going to be by doing the inverse tan of 9 over 2. So when we do that, we get 77.47 degrees. That's to 2 decimal places. So when we are solving this, that means we're going to have x is equal to 180 minus 77.47 and 360 take away 77.47. So we get our answers as 102.53 degrees and 282.53 degrees. Right, so this question was worth 3 marks. You get 1 mark for tan x is minus 9 over 2, and then 1 mark for each of your 2 values of x. Okay, so for question 15, we have a perfume bottle, and the label is in the shape of part of a circle, and we need to find the height of the label. I think for this one it kind of makes a wee bit more sense to put it inside our diagram there. So O to B, that point there here, is going to be another radius of our circle. So that's going to be 6.6 centimeters, and then we have some unknown value there. So if we can draw that out again as a triangle, makes it a little bit more obvious of what we're going to do. So that's 6.6, we could have a right angle there. The bottom is going to be 4.5, and we can use Pythagoras to find our third side. So we get a squared is equal to c squared minus b squared. So it's equal to 6.6 squared minus 4.5 squared. So we have a squared is 23.31. So a is the square root of that, which is 4.83. So that's rounded to 2 decimal places, and it's centimeters. So therefore the height is 6.6 plus the 4.83, which gives us 11.43 centimeters to 2 decimal places. Okay, so marks for this question. You get 1 mark for kind of knowing, reading the question, figuring it out, and getting the fact that there's the right angle triangle. You get your 2nd mark for correct statement of Pythagoras. You get your 3rd mark for a correct value for the height of the triangle, and then your final mark is for the correct height of the label. Right, so that is question 15, so we're almost finished. On to our last question, question 16. Okay, so as always, they finish with an interesting one. So what they have here is you have a diagram below, and they've told you that DE is perpendicular to AC, so that's the right angle in here. It tells you A to D is 4 centimeters. It tells you that B to D is 6 centimeters, and that these two are the same at 3. And we need to find out this bit here. So we don't have a right angle triangle, so we can't actually work that out straight away. But we can use the right angle triangle and find the angle in it to then find the angle here. So if we kind of split it first into our separate triangles, so we have this one here. So we have our 3 and we have our 4, and we have some unknown angle in there. Let's call it A, for ease, because that's given A, right? So we use SOHCAHTOA. Right, so this side here, so opposite there, that's the opposite. That one there next to it is the adjacent, and that's the hypotenuse. So we have adjacent and hypotenuse. So we are going to be using cos to find our angle here. So we end up with cos of A, because that's what we've decided to call our angle, or what I've decided to call it anyway, is our adjacent over hypotenuse. So we can put in our values, so we get 3 over 4. So cos of that angle A that we don't know. So we can find our angle A by doing the inverse cosine of 3 over 4. And we get that that angle in that triangle is in fact 41.4 degrees. Apologies, my dog is currently sitting asking for attention, so this might get interesting at the end of this. Right, so now if we ignore the small triangle and just look straight to the full one, so the ABC triangle. So we have B there, we have C, and we have A. So we now know that's 41.4 in there. That's 10, and that is 6. So we have A, which is what we want to find. That's little c and that's little b by our definitions of our cosine rule, because we have 2 sides in an angle, so that's going to be our cosine rule. So cosine rule is that a squared is equal to b squared plus c squared minus 2bc cos a. We put in our values. A is bc, so it's bc squared. It's going to be 6 squared plus 10 squared minus 2 times 6 times 10 times cos of 41.4. That should all be on one line. I don't quite have enough space because I didn't plan it out very well. So when we put that in our calculator, we get bc squared is equal to 46. So then BC is the square root of 46, which is going to be 6.0 centimeters. Right, so marks for this question. You get 1 mark for either getting cos A is 3/4 or A degrees is 41.4 degrees, so using trigonometry there. You get your second mark for correctly substituting into the cosine rule. So not for identifying that it is a cosine rule, but for subbing in properly. You then get your third mark for calculating that correctly as 46. And then your final mark is for your answer of BC once you square rooted it. Okay, so that's it for the 2016 paper 2. If you've got any questions about anything that I've done for here or want any extra examples, just leave a comment and I can get back to you. Thanks very much for watching. I hope that was really helpful, and there's more videos on here for different papers if you want them. Great, so thank you for watching again, and that's me for 2016 paper 2.